Ignore the shadows and the sloppy handwriting. I'm in a different room and I just scribbled this stuff down real quick while I was on the couch. In this video, I'm going to show some of the math for maximum ammunition efficiency. So in other words, how many shots should you fire at a target in order to be able to hit the target just once and not waste ammunition? This problem is interesting, I think, for the same reason that most of my problems I come up with are interesting. And that's because it's somewhat useful information to help us understand the world. And on the surface, it looks super complicated, but I'm going to break it down and make it look super simple. At least that's the goal. Also, this is interesting because this is an example of not being able to see the forest through the trees. When I made my first video on this, I was going into all sorts of detail because I was basically focusing on the bark or the trees, and I didn't back up and see the full picture. So I'll show what that full picture is. I'm going to be talking about the A10 Warthog here. Fires a whole bunch of bullets really fast at tanks, typically. But you could also use this math if you're just going to use a shotgun and have several pellets come out at once at a target. But the question is, how can you maximize your ammo efficiency? So here's the numbers. If you got the A10, it fires at 4,000 feet or from 4,000 feet away from the target. It'll have an 80% accuracy in a circle with a diameter of 40 feet. So when that planes up 4,000 feet from the target, 80% of its bullets will go into a circle with a 40-foot diameter or a 20-foot radius. Is the real information classified? I don't know. But if the actual numbers are different, the math will still be the same. Maybe there's no reason to classify this information. So say perhaps the enemy knows where the A10 will be when it's firing at 4,000 feet away, but they have no way to change their strategy to avoid that. So in that case, this information wouldn't be useful to the enemy. But then again, there's no reason for any military to go advertising information when they don't need to, or to borrow some terminology from Shaun of the Dead. You could really exacerbate things or find yourself in a spot of bother if you go advertising your whereabouts more than you already have. So here's some more information for this little math puzzle or math problem. Assume you only need one hit for a kill. For example, there's not a lot of empty space in a tank, so the bullet would either hit the engine, ammo compartment, crew compartment, fuel, or the tracks to at least get an immobility kill. And so the question, as I posed earlier, how many shots should be fired at each tank for maximum ammo efficiency? And this is not maximum fuel efficiency. Meaning if you don't fire as many shots, then you're going to have more misses and you're going to have to circle back and retarget the target and burn more fuel. Here's some other things too to think about just for fun. Assume the pilot isn't being shot at because that creates more chaos. And ignore the chaos of battle. Pretend the pilots don't prefer missiles over bullets because the missiles will give you an increased standoff and make it safer for the pilots, so you're not putting the pilots and the planes at as much risk. Those are multi-million-dollar planes. Also, imagine ideal circumstances. Say if you're creating the stats for a video game or something, you could also pretend this is late in the war, so you're going to have decreased resources. So you'll have to be as efficient as possible. During World War II, there was large amounts of rationing in all the countries involved because so many resources went to the war effort. Also, you can assume a target-rich environment, which means if you're wasting ammo and hitting one tank with multiple shots when you don't need to, then you're not going to have as many targets or as many tanks to target, so you have to keep going back to get rearmed. The Battle of Kursk comes to mind on that, so very large tank battle, or maybe you could say the Battle of 73 Easting. And then also, like I said here, statistics for a video game. So you got somebody flying an A10 in a video game, they pull the trigger and they shoot at a tank. What percentage of their bullets are going to go into that tank and what percentage of those bullets are going to hit the dirt around the tank? I figure a programmer would need some sort of information like that. Okay, next page. I'm going to metaphorically show the trees here by showing some exact numbers and exact calculations, but then I'm going to back up to 10 miles high and show the whole forest to show how simple this problem really is. All right, area of a circle. Circle area is pi r squared. The diameter of that circle will be 40 feet because when the A10 fires its bullets, 80% of its rounds will go into a circle with a 40-foot diameter. That's a 20-foot radius. 20 squared times pi gives you an area of 1,257 square feet. The area of a tank, according to Wikipedia or Google or whatever, wherever I got this information, about 32 feet by 12 feet. Multiply those together, you get 384 square feet for the area of the tank. Here's some more numbers. We take the 80% probability because 80% of those shots will go in that circle. That's accuracy in the circle. Times the ratio of the tank divided by the circle, those areas. So area of tank divided by area of circle, 384 divided by 1260, times 4/5, because 4/5 of those rounds are AP rounds or armor penetrating rounds. 1 out of 5 of those rounds are anti-personnel incendiary rounds. So they hit the ground and explode, so they're good for soft targets, but they won't penetrate a tank. So we use 4/5, multiply it all together, you get about 20%. So in other words, when the A-10 comes down and is shooting at a tank right here and say it fires 100 rounds, about 20 of those rounds will go into the tank, and the other 80 rounds will hit the dirt outside of the tank, or they'll be the anti-personnel incendiary rounds that just hit the tank and explode and don't do any good. Okay, so now we have the exact percentage. I'm going to back up and show the whole forest right here. 1 round per target is the most efficient, regardless of the accuracy of the gun. Here's the diagram that explains that. Let's say we have 10 tanks here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on each tank, we fire 1 bullet at it. So we'll call it bullet number 1. This tank will be hit right here with bullet number 1. This tank right here will be hit with bullet number 1. So 2 out of 10 tanks will be hit and killed. The other 8 out of 10 tanks will be able to escape or have to be retargeted. So now let's say we fire 2 shots at each tank. The first shot will be shot number 1. The next shot will be shot number 2. So here we have our 10 tanks right here. We're going to shoot at each tank twice. As I just showed, 2 of these tanks will be hit on the first shot and there'll be a kill. And most of the time, that second shot, labeled as number 2, is going to hit 2 separate tanks. So for example, bullet number 2 or the second shot could hit this tank and this tank, or this one and that one, or whatever. But occasionally, just statistically, it's going to happen. You're going to have both bullets hit the same tank. And now we have a waste of ammo because we have 2 hits on 1 tank. So while this is not a very large waste of ammo, we've only wasted 1 bullet here by having a redundant hit. This just shows the trend that the more bullets you fire at each tank, then the more redundant hits you're going to get on the same vehicle, and the more ammo you're going to waste. So for example, if you fire 100 bullets at each tank, then you're going to get a lot more redundancy and waste even more ammo. And granted, you're going to waste fuel or spend more fuel having to circle back to get all these other tanks that were missed. But again, that's why I said I'm just talking about ammo here and not fuel. Okay, next page. All right, here's some hard numbers to give us an idea of what's going on. If you only have 1 shot per target or 1 shot per tank, 20% of those tanks will be killed, 80% escape and have to be retargeted. So in that example I just showed, out of 10 tanks, 8 of them get away, 2 of them get killed. Now if we do 2 shots per target, I'm going to use the formula for the multiple draw probability. I did a video that showed how to derive this formula. It's actually really easy to derive and intuitive, so you can see that video if you want. It was on how multiple chances or multiple draws will increase your probability. So you take 1 minus your probability of losing, which is 8 out of 10. You take that to the exponent of the number of attempts. In this case, it's 2 bullets being fired, so it's like getting 2 draws from a deck of cards. So it's like having a deck of 10 cards, 2 of those cards are winners, 8 of those cards are losers, or they're the fails. So you take 8/10 to the exponent of the number of attempts or draws. And this is with replacement, so you draw a card and then put it back. And the way I got this 8/10 right here, or 80%, or 0.8, is because 20%, we have a 20% hit rate, which means we're going to have an 80% fail rate on every target. So we take 1 minus 0.8 squared, that gives us 0.36, or 36% kill rate, or 36% probability of a kill, which means 64% of the tanks are escaping and have to be retargeted. So 36% is a higher probability than 20% right there. So on the surface, it does look like you're better off firing more shots at each tank because you're going to have a higher kill rate. However, on the next page here, I'm going to show what that does to the efficiency or how many bullets we're wasting. If we have 100 targets, we're only going to fire once at each target. once per target. That means we're firing 100 rounds. We're going to get a 20% kill rate out of those 100 rounds, 20% efficiency. Now if we do 2 shots per target, we're going to get 36 kills because we have right here a 36% efficiency, but we had to fire 200 rounds to get that instead of 100, so 36 divided by 200, 18% efficiency. Notice the 18% is less than the 20. And again, that's from the redundancy that I showed earlier, where you're occasionally going to get 2 bullets hitting 1 tank. Feel free to plug in your own numbers, so instead of shooting at each tank twice, you could shoot at each tank 10 times or 100 times or whatever. All you do is replace that 2 exponent with however many times you shoot at each tank. That was the initial approach I took when I shot this video the first time, because I didn't realize the trend, how it all comes down to this diagram right here, just showing that you're going to have increased redundancy the more times you shoot at each tank. So you will have increased first pass efficiency. So as this, say, gets up to, say you fire 100 shots at each tank, you'll essentially kill every tank on a first pass. It'll be like 99.999 or something. So you'll have a lot of first pass kills and not have to go back and retarget anything, but you'll just have decreased ammo efficiency because you'll have a lot more redundancy with several bullets hitting each tank. So I think this problem is interesting to think about, because then you can start thinking about which is more valuable, the bullets or the fuel. And if it's late in the war and you get into a situation with, for some reason, you have possession of the oil fields, so you have a lot of oil or a lot of fuel, but you don't have very many depleted uranium rounds for your bullets, then you may not want to shoot as many bullets at each tank on that first pass, let some of them escape, and then circle back and target them again.